Hello viewers, welcome to Simplified Maths class. And today we are going into the last aspect of quadratic equation, roots, perfect squares and undefined expressions. Alright, so here you'll be given roots of a quadratic equation to find the equation. You'll be asked what was the added to the expressions to give a perfect square, and then what should be the value of x to make the expression undefined. So we'll go straight to point. So we have the questions already here, so we'll take them one by one. We'll begin with the first one. It says find the quadratic equation whose roots are these. Number one, so we have the I. So they say we should find the quadratic equation whose roots are minus 3 and 7. So the roots are minus 3 and 7. So we want to find the quadratic equation. So it means x will be equals to minus 3, and at the same time x will be equals to 7. Those are the roots. Alright, so x minus 3 will cross to be plus 3 equals to 0. Here plus 7 will cross to be minus 7 is equals to 0. So we are going to have x plus 3 being multiplied by x minus 7, and both are equals to 0. So we factor them out, we multiply. X times x will give us x squared. X times negative 7, that's negative 7x. 3 times x will give us 3x. And then 3 times minus 7 will give us minus 21 is equals to 0. So it means we are going to have x squared minus 7x plus 3x will give us minus 4x. And then minus 21 is equals to 0. It therefore means that this is a quadratic equation that has this and this as the roots. Alright? So we'll take the second one, II. The roots of the quadratic equation are roots are 2 over 3 and minus 1 over 3. It means that x is equals to 2 over 3, and then it also means that x will be equals to minus 1 over 3. Alright, so we want to bring them out. So this will be over 1, this will be over 1. 3 times x will give us 3x, alright, equals to 1 times 2 will give us 2. Here 3 times x will give us 3x, equals to 1 times minus 1 will give us minus 1. So we equate it to 0, so this becomes 3x plus 2 will cross to be minus 2 is equals to 0. Here we'll have 3x minus 1 will cross to be plus 1 is equals to 0. So it means that 3x minus 2 as well as 3x plus 1 is equals to 0. So we'll multiply them out. 3x times 3x will give us 9x squared. 3x times 1 will give us 3x. Minus 2 times 3x will give us minus 6x. Minus 2 times 1 will give us minus 2 equals to 0. Here we are going to have 9x squared. 3x minus 6x will be negative 3x minus 2 equals to 0. So it means that it is this quadratic equation that will have this and this as the roots. So we are done with number 1. We are going straight to number 2 without waste of time. Alright, so let's go straight to number 2. In our number 2, they want us to find the quadratic equation that will have, alright, sum of roots and product of roots. That's our number 2. Okay, so here, number 2, they've given us sum of roots. The first one, they say the sum of roots is 7, because sum and product of roots, this sum, this is product. So the sum of roots is 7, and we have the product of roots. Product of roots is equals to 10. So we want to find the quadratic equation that has 7 as sum of roots and this has product of roots. Please take note, the required equation is always x squared minus sum of roots x plus product of roots equals to 0. That is a required equation. This is how it must be expressed. So we are going to have x squared minus sum of roots. What did they give us? Sum of roots 7. And then we put the x plus what did they give us? Product of roots 10 equals to 0. So we are going to have x squared minus 7x plus 10 is equals to 0. It therefore means that it is this quadratic equation that has sum of roots, meaning that when you factorize or you complete the square or you find the roots by formula method, when you have those two roots of this quadratic equation, when you sum them, the addition of the two roots will give us 7, and the multiplication of the two roots will give us 10. It's as simple as that. So we are done with the I part. So we take the II. All right, let's go to II. II. So we should find the quadratic equation whose sum of roots is minus 5 over 12. So sum of root is minus 5 over 12. And then product of root is what? Minus 3 over 12. As simple as that. So let's go. The required equation is x squared minus sum of roots x plus product of roots. So we are going to have x squared minus, what did they give us? Sum of roots? Minus 5 over 12. We put our x there, plus, what did they give us? Product of roots? Minus 3 all over 12 equals to 0. That's simple. So we are going to have x squared minus minus will become plus 5 all over 12x plus product of root, which is minus 3. So plus and minus will become minus 3 all over 12 is equals to 0. So at this stage now, because we have a denominator of 12, it means we'll multiply through by 12. Multiply through by 12 to destroy the fraction. Multiply through by 12. So we're going to have 12x squared. We have multiplied by 12. Here we are going to have 12 being multiplied by 5 over 12x. 5 over 12x. Here we are also going to have 12 again being multiplied by minus 3 over 12 is equals to 0. So we are multiplying all the terms by 12 in order to eliminate the fraction. Alright, so we are going to have 12x squared. This 12 will cross out this 12. So we only have plus 5x. And then this 12 will cross out this 12. We only have minus 3 is equals to 0. It therefore means that when you take this quadratic equation and find the roots of the quadratic equation, at the end of the day, when you sum them, the roots, you have minus 5 over 12. And when you multiply the roots, the two roots, you have minus 3 over 12. So we are done with number 2, which we are trying to find the quadratic equation with given sums and product of roots. So we'll go straight to number 3. These are the aspects of quadratic equation people run away from because, they just tell you to do these things. Number 3, they say what must be added to the expression to make it a perfect square? Number 3 of I. We have been given an expression x squared plus 5x plus 3 equal, okay. All right, so they want what term will be added to this to make it a perfect square. So in order to derive that, you're going to use those first 3 rules in completing the square as we have taught you before now. So one of it is number 1, you divide through by the coefficient of x squared, which is 1. So you're going to have x squared all over 1 plus 5x all over 1 plus 3 all over 1. So we are dividing through by the coefficient of x squared. And the coefficient of x squared here is 1. So we are going to have x squared plus 5 over 1, alright, 5 over 1x plus 3 over 1, alright, which is still 3. 3 over 1, which is 3. Here, x all over 1. So the essence of this is to find the coefficient of x, because the next rule is for you to multiply the coefficient of x by half and square it. So we are going to have x squared plus 5 over 1x plus 3 plus, which is the new term we want to add now. So we take the coefficient of x, which is 5 all over 1, multiply it by half, and then square it. Alright, the rules we used to take when we are working by completing the square. If you've not been conversant with completing the square, please look for the video completing the square that I've prepared. You see it in details. But here we are just looking for the term that must be added. So you have x squared plus 5x plus 3, which is still what you were given before. But a new term now has been added. 5 times 1 is 5. Alright, 5 squared will give me 25. All over 1 times 2 is 2. 2 squared will give me 4. It therefore means that it is this that has been added to the expression to make it a perfect square, 25 over 4, as simple as it is. So let's try the second one, II. In the second one, II, we have 3x squared minus 7x minus 2 what must be added to this equation now to make it a perfect square? It's the same thing. We'll apply the first rule, which is divide through by the coefficient of x squared. This time around, the coefficient of x squared is 3. So we are going to have 3x squared divided by 3 minus 7x divided by 3 minus 2 divided by 3. All right. So we divide through by the coefficient of x squared. So when we do that, 3 crosses 3, we are going to have x squared minus 7 all over 3x minus 2 over 3 is equals to 0. So all we need now is to take the coefficient of x, multiply by half, and square it. All right. So we are going to have x squared minus 7 all over 3x minus 2 all over 3. Now I want to introduce a factor, which is the coefficient of x being minus 7 over 3. So we take minus 7 all over 3, multiply by half, and then square it. Okay, that's what we want to do. Is equals to 0. So this is a term that is added to make it a perfect square. So it means you're going to have x squared minus 7 all over 3x, then minus 2 all over 3 plus. All right. So what is that term that is added to make it a perfect square? Minus 7 times 1 is minus 7. Minus 7 squared will give us 49. 3 times 2 is 6. 6 squared will give us 36. It therefore means that it is this term now that is added to the quadratic equation given here to make it a perfect square. It's as simple as that. So this is what must be added. If anything will divide, you can decide to divide it down, assuming something can divide, but I believe nothing will divide it. So it's as simple as that. So we are going into the last aspect, which is find the value of x for which the expression will be undefined. Let's go straight to that. So for undefined expressions, you have to note that for an expression to be undefined, the denominator of that expression must be equals to 0. For any expression to be undefined, the denominator must be equals to 0. So what must be the value of an expression to make it undefined? Assume you have 10 all over 0, it is undefined. That's why if you press 10 divided by 0, your calculator will tell you error. That's undefined. 800 divided by 0 is error, undefined. So anything you have divided by 0 gives you an undefined expression. So for this case where you are looking for the value of x to make the expression undefined, it means the denominator must be 0. Number 4. Now what is the denominator? The denominator here is the whole of x minus 2. That's the denominator. So for the expression to be undefined, x minus 2 must equal 0. That's what we are saying. So it means that x will be equals to, minus 2 will cross to be equals to 2. It therefore means that for this expression to be undefined, the value of x must be 2. And it's true, because if you have x here to be 2, 2 minus 2 will give you 0. And whatever you divide by 0 is undefined. So you are true with that. So we take the next one. This was I. For this expression to be undefined, the denominator here, which is 2x plus 3, must be equals to 0. Alright, so 2x will be equals to plus 3 crosses to be minus 3. X will be equals to minus 3, 2 divided by 2. It therefore means that for this expression to be undefined, the value of x will be minus 3 all over 2. Wow, would that be true? Okay, let's see. Watch me. 2x plus 3. We want to see whether it will give us 0. 2 into x now has been calculated as minus 3 all over 2. Alright, so plus 3. Will it give 0? Is what we want to see. 2 crosses 2. Minus 3 plus 3. What will you have? 0. It therefore means that if x is minus 3 all over 2 and is put here, the whole of this will become 0. And when once the whole of this becomes 0, the expression becomes undefined. So for every undefined expression, the denominator must be equals to 0. So this will be the values of x. So it's as simple as it is. Thank you very much for watching this last aspect of quadratic equation. I want you to click on the thumbnail, which is like, and then subscribe to our videos in case you have not subscribed, so that whenever we come up with exciting topics in mathematics, it will pop up for you to watch them. God bless you, and see you in our next slide. Cheers.